Hi, this is Josh from Over the Shoulder Coding, and today I'm showing you how I'm going to solve the Advent of Code 2018 Day 3 challenge. So, what's the challenge for today? On day 3, the elves managed to locate the chimney squeeze prototype fabric for Santa's suit, thanks to someone who helpfully wrote its box IDs on the wall of the warehouse in the middle of the night. Unfortunately, the anomalies are still affecting them. Nobody can even agree on how to cut the fabric. The whole piece of fabric they're working on is a very large square, at least 1,000 inches on each side. Each elf has made a claim about which area of fabric would be ideal for Santa's suit. All claims have an ID and consist of a single rectangle with edges parallel to the edges of the fabric. Each claim's rectangle is defined as follows: the number of inches between the left edge of the fabric and the left edge of the rectangle. So this measurement. The number of inches between the top edge of the fabric and the top edge of the rectangle. So this height. The width of the rectangle in inches and the height of the rectangle in inches. A claim like number 123 at 325 by 4 means that the claim ID 123 specifies a rectangle 3 inches from the left edge, 2 inches from the top, 5 inches wide, and 4 inches tall. Visually, it claims the square of inches of fabric represented by the pound signs and ignores the square inches of fabric represented by the dots in the diagram right here. The problem is that many of the claims overlap, causing two or more claims to cover part of the same areas. For example, consider the following claims. Claim number 1 at 1, 3, 4 by 4. Claim number 2 at 3, 1, and also 4 by 4. Claim number 3 at 5, 5, and 2 by 2. Visually, these claim the following areas. The 4 square inches marked with an X are claimed by both 1 and 2. Claim 3, while adjacent to the others, does not overlap with either of them. So this area is marked by claim 1, and then this area all the way to here is marked by claim 2. If the elves all proceed with their own plans, none of them will have enough fabric. How many square inches of fabric are within 2 or more claims? Okay, so it seems like what we need to do is to figure out the size of the area here x'd off. And to do that, we need to keep track of all the claims, the area claimed by all the claims. So like here, this is the area claimed by claim 1. So we will probably make a map of the area on the fabric and by how many claims it's claimed by. So here, like this area, uh, 1 over and 3 down would have 1 claim. But this area 3 over and 3 down would have 2 claims. And so we will have the key in the hash map be the location on the fabric, and the value of the hash map be how many claims are claiming it, so the count of claims claiming it. And as we go through these claims and uh, add these areas to the hash map, whenever a entry has a value of 2, meaning that it's been claimed by 2 places, we'll increment an area counter. So when we put in 1, nothing will have a value of 2, but then when we put in 2 and we iterate through this and we get to here, then we'll increment the area counter for areas claimed by at least 2 claims. And then increment it again when we get to here, do nothing for the 2's over there, then increment it for these 2, then do nothing for there. So let's try that. And these are all the claims. There are over 1,000 claims. So The first thing we're going to do is try to read a single line and then split it into the claim ID, the x coordinate, the y coordinate, the width, and the height. So let's get the first line. Right. That's this line, and we're going to try and strip it and split it. So let's try and strip all the spaces as well. All right, I'm going to try to figure out how to slice from this Python string. All right, looks like we're going to have to use regex parsing, something like this. So I've made a regex string to identify this string and try and pull out these sets of numbers. So here's our regex string, and we want to find these. So let's see what happens here. Run this. We want the group. Oh, that doesn't do much. All right, so I don't know a great way of extracting this, but we can do a really dumb way of extracting this. So we'll make a method to extract the parameters. So we will have a 5 names: the claim ID, the X, the Y, the width, and the height, all equal to 0. And for range time, we can start at the first one because we can skip the first found character. We can get the claim ID from going print line dot split on spaces. So claim ID, we split on spaces. Claim ID is the first one here as an integer. So we can get the claim ID. We can ignore the @. Then we can split this based on the comma. We'll remove the colon at the end, then split on comma. And print locations. We get those two. So the x is equal to locations, the first one, and y is equal to the second one. And let's see, the last part is the x. So width equals size equals split on space 3 dot split on the x character, and width equals int size 0, and height equals int size 1. So we have our 5 values, and then we're going to return claim ID, x, y, width, and height. So let's try that. We get 1, 286, 440, 1924, which is exactly what we expect. So works great. For line and lines, claim ID, x, y, size, width, height equals extract parameters line dot split. All right, and then we're going to do what we said in the beginning, and we're going to have a dictionary keeping track of how many times each location has been counted. So num claims on location equals default dict of an integer, and we're going to import that default dictionary class. Don't need our regex class anymore. And then for width, find range width, and for j in range height, we're going to increment the count so I'm going to say point, we're going to make a tuple, or yeah, just a tuple, a point location, next y location of x plus I and y plus j. So we're going to iterate over that patch, like the patch of this. We're going to iterate over it and then increment the count in our claims on location. So num claims on location point plus equals 1. And if num claims on location point equals 2, area claimed by at least 2, we're going to increment that. And when we're done iterating over all lines, and when we're done iterating over our lines, we will print the area claimed. Okay, let's see if that's the right answer. All right, we got 1 gold star, and we can continue to part 2. So for part 2, amidst the chaos, you notice that exactly 1 claim doesn't overlap by even a single square inch of fabric with any other claim. If you can somehow draw attention to it, maybe the elves will be able to make Santa's suit after all. For example, in the claims above, only claim 3 is intact after all claims are made. What is the ID of the only claim that doesn't overlap? Oh man, okay. So we already found, let's copy part 1 first. So instead of a dictionary of integers, what I'm going to do is a dictionary of list. And each list is going to be a set. And the set is going to be the set of claim IDs. We don't need that. So we're going to append the claim ID in this list or push it onto the set. And then at the end, we're going to see which key only had a set whose value was 1. And we can do that really quickly by if set dot length. If the length of the set is greater than 1, we will stop keeping track of that claim ID. So possible claims equals an empty set for now. And then if the length of the set is equal to 1, possible claims, we'll add it. So if the claims on location, if claims on location So if the length of the claims at this point is only 1, we'll add it to the set of possible claims. Well, otherwise, if the length of the claims is greater than 1, it's no longer a possible claim. We'll remove it from and at the end, we should only get 1 claim ID back. So maybe instead of possible claims, we'll say unique or non-overlapping. So let's run this, part 2, and see what happens. All right, so something is happening. So we're adding the claim ID to unique claims, but if the length of the claims is greater than 1, We need to remove all claims that are in there. We're removing quite a few, but not all of them. So maybe instead, after we're done looking over all the claims, we'll just do a search. The n squared over the size of the fabric, but not terrible. Hmm. Okay, X, Y, claim. How about that? So it seems like this claim, all claims only have length 1. So we'll want to print claims. So we'll print it here. So I'm worried that I might not be doing the math correctly, but seems like we should. Let's try it on a smaller scale and see if we can get the right answer. So those all double. There's no unique claims. Let's see what the map looks like. So for point 1, 3, we have claim 1. For 1, 4, we have 1. For 1, 5, we have 1. If we have 1, 6, we should have 1 and 2. So this, okay. So for 3, 3, should have 1 and 2. Got it. So instead of unique claims, we want to have the length of the claims at that point is 1. We can add it to possible unique claims. But if the length of the claims greater than 1, we're going to add all those claims to definitely not unique claims. So we have a list of claims that are possibly unique, or a set of claims that are possibly unique, and then a set of claims that are definitely not unique. And we want to find what's in possibly unique that's not indefinitely unique. So we're going to find the difference between the possible ones and the definitely not ones. Hopefully there should just be one. Oh, and it's 3. So that works pretty well. Let's try it on the bigger set and see if it works there too. 1046. Let's test that. All right, solved day 3. So what we did for part 1 is we found a way to extract all the parameters, and then we found the number of claims. So we had a number of claims dictionary, and we incremented the number of claims each time we got to a point that was in one of the claims, and we incremented it. And if the number of claims on the location for that point was 2, we would increment the area claim by at least 2 claims. We could print that out. And for part 2, we went through all the claims again, and instead of just incrementing the counter, we added that claim ID to a dictionary of claims on that location. And if the length of claims on that location was exactly 1, it was possibly a unique claim. But if for all the points, if the claims on that point ever increased over 1, then we would say for all the claims at that point, they're definitely not unique claims. And then we did a difference of sets. So what is in possible unique claims minus what is in definitely not unique. And we only had one answer, which was 1046. And we submitted that. So thanks for watching. If you like this video, give it a thumbs up. Subscribe to my channel so you can see me solve the next problem, day 4. And if you can, please support me on Patreon. It really means a lot to me. Thank you.